Welcome back, dear students, to the physics vision classes. The given question is phi, a function of x, y, z and t is given as this, cos of this and real part of this x plus iota y. Okay, and what has been asked in the question that this function satisfies which of the following wave equation. So these are the different forms, and we have been asked that which of the form is satisfied by this given function. Okay, so it's a very lengthy question and a very good question. One thing is that you can answer it directly by observing the equations in the options, that only one A is the actual wave equation. All others are differing with certain sign, and those are not the exact forms of the wave equation. Okay, we'll go other way around. We'll prove it that the given function is satisfying the wave equation or not. For that matter, firstly we need to calculate the value of this real part of sine x plus y. So let's calculate this part first, which is given as real part of sine of x plus iota y. What is sine a plus b? By using the formula sine a cos b, this becomes sine a cos of iota y plus cos a and sine of iota y. Okay, now making use of the hyperbolic functions properties of their values, we know that cos iota y is cos y and sine iota y will be iota times of sine hyperbolic y. Substituting the values here, we got the real part as this. The bracket is sin x into cos hyperbolic y plus iota cos x into sine hyperbolic y. Okay, so this is the imaginary part and this is the real part. So taking it out, this is the real part. We got the function as sin x into cos hyperbola y. We'll take it this phi as cos z minus vt plus the function was sin x into cos hyperbolic y. So this is our function. Okay, this is our function phi, and we need to check which of the following equation does it satisfy. How will we do it? We'll take the derivatives all and just observe the sign in all the cases. Let's see that. What is derivative of phi, double derivative of phi with respect to x? So x is in this term only. With first derivative it will be cos x, in the second derivative it will be minus of sin x. Okay, and cos hyperbolic will remain the same. Next factor is phi of y, which gives us derivative of cos hyperbolic y is sine hyperbola y, and sine hyperbola y derivative is cos hyperbola y. So we got the same value, absolutely same value with the same sign here. Okay, third part is derivative with respect to z. It will be in the first term, and derivative of cos is sine minus and sine is cos. So it gives us the value as minus of cos of z minus vt. And when we will see the fourth derivative, that is double derivative with respect to t, we'll get of course minus cos z minus vt, and this minus v square will also be taken in this case. So that becomes minus of, or 1 by v square of curly square phi by curly t square that is double derivative, is equal to minus of cos into z minus vt. Now you can see that these two values will be added up, will give you 0, and then these two terms will be equal to each other. Hence we need all the positive signs here and here, and thus A is the correct answer to this question, option A, which is the exact form of wave equation. Okay, so you'll make use of the options or the correct understanding of the physical problem, then you can do it very easily and very quickly. It's a matter of a few seconds only. Otherwise you will go with the proof, the full mathematical steps, and then it can be done. It will take a few minutes, a couple of minutes. Okay, so stay tuned with us for more such questions and doubts, and thanks for watching this video.